All right, thanks everyone for being here today. Appreciate you all joining us for a great conversation on Unity's XR Interaction Toolkit. My name is Doreen Brown. I'm a product manager at Unity focused on the XR input and interactions initiatives. Prior to working at Unity, I actually was at Microsoft working on MR initiatives within the org.
And I'm Dave Riddell. I'm the engineering manager over at Unity in charge of XR input and interactions, things like the XRI toolkit that we're going to talk about today.
All right. So why don't we first start with an overview of how we're going to spend roughly the next 40 minutes. We'll first start with an overview of the XR Interaction Toolkit, what it is, why it's important, and how you can start using it for your next project. We'll then get hands-on with two demos. The first demo being a video of an app that you can build with the XR Interaction Toolkit. The follow-up being a demo in the Unity editor of the app we'll show you, showcasing how and why the XR Interaction Toolkit is critical to the success of that app. Finally, we'll follow up with a roadmap, what's new, upcoming release plans, and overall feedback we're receiving on the toolkit as we move forward with our future plans. So what is the XR Interaction Toolkit, or as you'll refer to me talk about it pretty frequently, XRI? XRI is a Unity-made and managed package that provides a high-level interaction system, giving creators a jumpstart on building interactive and intuitive AR and VR content. This includes things like a robust framework with components and APIs to handle a bulk of the primary boilerplate needed for creating this highly interactive content. All of this is done with a layer on top of input to deal with delivering actions and events to the interaction layer. This brings support to XR devices that implement a Unity XR SDK, including OpenXR. We've also worked hard to expose input via both the legacy input manager and the input system. But that's a whole lot of words to describe something that's very visual. So why don't we take a look at an app that's built using XRI? And now I'll hand it off to Dave, who will go into depth about how the app works and how you can use XRI to build your own projects.
Cool. All right, so one of the things that I want to go over is what is included with XRI. What do we give you to get started to make your building journey easier? First of all, I want to explain where XRI sits on the stack in terms of everything in Unity. So as you can see from the stack image, we sit right below the application layer, so your VR and AR applications, and we sit next to the other packages that are critical to building your application, such as AR Foundation and Mars. Below that, you can see the XR plugin framework, which exposes all of the nitty-gritty. So you can build your application with XRI and not even have to worry about anything below there. Or you can if you want to. If you really need to get low level in the DLLs and things like that, you can. But we try to abstract away the harder stuff that lets you get creating quicker and easier while maintaining the greatest platform reach. And so you can see exactly how many platforms we support. So as you start to build your AR and VR games and applications, what core components are really required and provided by XRI? To begin with, you have your XR origin. We've wrapped this with some nice creation tools that allows you to create an origin, creates your play area, along with your left hand and right hand, and then controllers depending on which input model you're choosing. So the XR controllers, you can see we have two of them there. We have the action-based controller, which is wired directly to the new input system package. We also have the device-based, which is wired to the legacy input manager. But keep in mind that if you are using OpenXR, we only currently have support for the new input system, so you'll be using the action-based manager or action-based controllers. So below that, we have the actual interaction model. So this is a pattern that's starting to show up a lot in the industry. We have interactors and interactables. So what is an interactor? This is a component that lets you perform actions upon anything in the scene that you wish to interact with. And we tag those things with an interactable component. So our interactable components let us do things like pick stuff up, affect physics, place things in sockets, things like that. And the interactors are what we use typically on our controllers to deal with those interactables. We have three main flavors. The two of them that are the most important are probably the direct interactor. So that's for near field interaction, so things like picking things up, pushing things, manipulating physics in the near field. And then we have the ray interactor, so grabbing things from a distance, object manipulation, things like that, as well as UI interaction. And the last one on the list is the socket interactor. And this is kind of a special case. This works with the grab interactables, but this can be placed on almost anything in the scene where you want to place a grab interactable or any kind of interactable that you want to place in a specific socket. So in the example you saw, like a key in a keyhole or a battery in a battery holder, things like that. So where you want that pairing of interaction to happen. And the thing that sits on top of this that manages all of that is what we call our interaction manager. And this handles the state of all of the interaction loop. So it goes through each interactor, each interactable, each frame, says which things are actually designed to work together right now, which things are supposed to be interacting, and it obeys what we call our interaction layer mask. This works exactly like the Unity physics layers, so anything that you want to actually interact together will be on a layer together. Things that you don't want, you put on a separate layer. So this could be things like the teleport. So if you want to teleport to a specific location or you want to designate interactables that are only for teleportation, you tag them on an interaction layer for teleport. If you want to deal with things in the near field versus the far field, you can set up interaction layers specifically designed to handle near and far interactions. On top of that, now that we've kind of defined the main interaction model, now we have additional capabilities that we've added into XRI that we feel are essential to any XR content. So first and foremost is locomotion support. So we built in some teleportation capabilities with directionality coming soon to be able to point which direction you want to land when you're coming out of your teleport. We've got continuous move and turn, letting you use your thumbstick to move in a first-person control throughout the scene. And then snap, turn, and turn around. So with customizations to snap between the different angles, and that's customizable. So if you want to turn at a 45-degree angle or a 90, that's totally up to you. So in addition to locomotion, we've added haptic feedback into our interactors. So the interactors have configuration for different events when you're actually wanting to trigger haptic feedback. So hovering on things, picking things up, all of these things you can customize how the haptic feedback is triggered. So the intensity, the duration that will happen, which hand it's going to vibrate on. And then also everything is fully customizable, so you can build on top of that, and you could build much more extravagant haptic models if you wanted to. In addition to haptic feedback, we've added some basic visual feedback. So we have things like hovering on grabbables, hovering in the sockets where things are going to go. I think you saw the video where the battery was hovering. Before you let it go, it shows like a blue outline. So all of those affordances and things are built in. We've also added reticle system, so anything that you're pointing to in the scene, UI, things like that. We've got customizable reticles for all of the different flavors. You can customize them per grabbable, not just for the entire system. So anything that you want to have a special case is very flexible. On top of that, we've got our UGUI canvas support. So Unity has they have the UI toolkit and the UGUI. Currently, we only support UGUI. We've built a custom XR input manager or input module that handles all of the interaction between our XRI toolkit and the event system. In addition to that, we've also built in support for things like keyboards, mice, joysticks, gamepads, things like that. So you have a little bit more flexibility into how the UI is navigated when not in XR. A new feature that we've added recently is what we call intention filtering. This is a new kind of concept that we've put in there. This is essentially filters that allow you to define specific heuristics for selecting things. So when you're hovering between two objects evenly, what is going to determine which one you're actually picking? It could be the last one you picked, it could be the one that you're closer to on a collision, or it could be the one that you're looking at. So these intention filters we've added so you can customize the way that people are interacting with the objects and what they most likely intend to do. If they're looking at an object and they're holding the controller between two, the assumption is that they're actually trying to pick up that one that they're looking at. And all of these things go into our intention filtering engine, and they're all scored. So you can actually have all of them stacked on top of each other and scored depending on which priority you want these intentions to be. That's something we just released last month. Highly encourage you to check it out. Next thing that we added recently is a comfort mode sample. So this is a simple tunneling vignette. It just kind of shrouds your view. You can change the aperture, the color, the ease in time, ease out time. And this just drops as a prefab onto your main camera and lets you customize it from there. And then on top of all of this, just wanted to point out again the robust extensibility. If you've been paying attention to the MRTK3 release, you've seen that it's built on top of XRI, and that's kind of a testament to exactly what we built it to do, is to be extended and built upon as a framework for you to get going quicker. So if you're doing AR, which I assume a lot of you in this room are, you're going to want to install AR Foundation in conjunction with XRI, and this will actually enable additional AR features specific to the XRI module. So if you have not dealt with AR Foundation in Unity before, AR Foundation is one of our Unity-built packages that allows creators to build AR games and apps on top of the well-defined AR platforms, such as AR Core for Android, ARKit for iOS, HoloLens, and Magic Leap. So the AR functionality that we provide with XRI on top of AR Foundation are things like an AR gesture system, which maps screen touches to gesture events. It also allows for placement of AR interactables as virtual objects into your real-world mapping. In addition to that, we have a translation layer that takes AR gestures and interactables and translates common gestures such as placement, selection, translation, rotation into manipulations of your AR objects in your AR world. And last, we have AR annotations, allowing you to mark annotations on objects, AR objects in the real world, so other people who are experiencing it will see what annotations you left. And many of these features of XRI and AR Foundation together are actually showcased in Unity's AR Companion app, which just released a couple months ago. On top of being a really cool showcase of what you can do, it's a very useful tool for AR developers, and I highly encourage you to check it out. It's free on the Apple App Store. So now we have some time, and what I wanted to do is dive into the editor and kind of show you how things are wired up in the sample that you saw earlier. I think that'll help kind of show exactly how we've structured things and kind of go from there. Let's take a look here. All right. I kind of blew this up, so hopefully everybody can see this okay. All right. So in our scene, what we have is a few prefabs to get you going in our sample project. First, we have our complete setup. Now, this is wired with the origin and the interaction manager and things like that I've talked about. So the interaction manager is here. That controls all the interactions between the interactors and interactables. And I'll show you some examples of how the interactables are wired up in the scene. We have the event system, which is wired to our UI. And over here, you can see our input module and how you would customize that. So things like point, left click, scroll, all of the things that you would expect to be able to do with the UI, you can do with this input module. And it's fully customizable through both our input system with our default input actions, as well as the old input manager. So if you're not using OpenXR, you can turn on the old input manager and use it that way. So on the XR origin itself, we have personally wired it up with all of our locomotion providers. So things like being able to do the snap turn, continuous turn, teleport, dynamic movement, and all of these have specific things that you can customize about them. So as you build out your own projects, you can see how the locomotion's wired up. So we've wired it to a primary 2D axis on the controller for the left hand. So the other interesting thing here is that we've added some additional nuance to the project, which allows you to switch the handedness. So being able to switch locomotion between hands. So maybe you want teleport on one hand and your standard, FPS controls on the other, and you can swap that around. And we've got scripts that are set up to kind of walk you through how to do all of that. In addition to the actual locomotion providers, we also have just our standard Unity character controller, which handles physics and movement through the scene. As you can see, the main camera is kind of what you'd come to expect. It's just a track pose driver. We're not doing anything extra special there. But underneath is this tunneling vignette prefab that I talked about earlier. So I will expand this so that you can kind of see here. So, and then check out the game view. So you can see here, right now this is with the vignette effect turned on. So you can affect things like aperture size, and these are things that you pre-configure. You can also change them at runtime, but these are triggered by the locomotion provider. So as you're moving, it will automatically trigger the ease in effect for the vignette shroud to come into your vision. And you can write your own locomotion providers and plug them in if you wish. And you can also add additional custom effects if you wanted to, on top of just color and feathering effect and things like that. Now on the hands themselves, we have our controllers. So this scene is enabled with OpenXR, so we're using our action-based controller. And as you can see as we go through here, we have the standard things that you'd see in a track pose driver, such as position, rotation. But then we have these abstracted actions that we call select, activate, UI press, haptic device, things like that. And these are all wired through, again, the new input system. So you can see we've categorized them by hand, and then you can customize how each of these things comes through. So right now we've got the UI press mapped to the trigger, select is mapped to grip, and so on and so forth. So you can customize that however you want. That's kind of the power of the new input system, is being able to have that flexibility. You'll also notice, if I jump back there, that all of this is wired through with just the XR controller reference. We're not referencing any specific devices, so we're not saying this is only for the HoloLens or the Valve Index or anything like that. It's handled, as I talked about, the abstraction layer, so all of the devices are managed the same under the hood. But if you wanted, for instance, the trigger to be a little less sensitive for Valve Index or something like that, then you can come in here and you can create a new binding for that and customize it that way. So in addition to the hand, now we get to the actual interaction piece of it. So that controller hands off those select and activate actions and things like that to the interaction manager, which then tells the interactors what to do. So you can see here's our direct interactor, which we'd use to grab things up close. And this is going to be looking for a select action. So anything where you're grabbing things or picking it up, it will trigger that state, and then you can activate it by, in our scenario, by pulling the trigger. And I'll show you an example of how that's wired up with the blaster here in a minute. But the one thing I did want to show you is that there is the ability to fire audio events, haptic events, and additional interactor events on all of these interactors. So as you're picking things up, hovering over things, you can trigger sounds, haptics, and any of your other custom code that you want to wire up. And when you're looking at this, keep in mind that this is all no code, right? You could, if you have your own scripts, you can drop them in, and now you can just start wiring it up without having to write any lines of code, which is super cool because it gets you up, pretty quick and easy. I will say that this sample project has a lot more stuff in it that helps you get up and running than just the base XRI package itself. And so hopefully, in the next couple of months, this project will be available for all of you to check out. And let's see here. So you've seen that. So let me show you a little bit of how the interactors or the interactables work in the scene. Let's see here. So I mentioned the blaster, so we'll go fly over to the blaster here. So, or the launcher, sorry. So the launcher is just an XR grab interactable. So it's something you can grab and pick up. We've got all of these other options, knobs and dials set up, purposely for the launcher. One thing that is an interesting thing to keep in mind is we have a attach transform. So this is exactly where your hand will attach when you pick it up. So that's custom defined for any object. So as you can see, it will snap your hand to the handle so you're not picking it up in some random spot that you don't actually want it to be attached to. And then if we expand the interactable events, this is where on activate, so you're holding it, now you're pulling the trigger or whatever the activate button is, and it's going to perform two actions. It's going to set an animation for the fire state, and then it's also going to launch a projectile. So again, all of this stuff is wired up in the editor rather than through code, but you could do it either way. And last but not least, I wanted to show you briefly the socket interactors and interactables. So here we have a simple battery. This is another just grab interactable. So you can see here, we've got our grab interactable. We've added something that we call a keychain to it. This is something that we came up with that allows you to define a specific set of interactable objects. So instead of just using the interaction layer mask, we've actually set it up so that the battery slot will only accept things that are keyed to the right thing. So this is a closed socket, so it only will accept a specific key. Look at the lock, we see what the required key is, and it's the battery socket key. And the battery holds that key, so when you go to push it in there, it will say, yes, this is the right one, and you can let it go, and it will actually then, if we look at the interactor events, you can see what happens when it actually enters the select state. It will actually turn on the Perler machine, or the giant light bright, if you will. So it sets that active when the socket has something in it, and when you pull it out, it will actually disable that. So pretty simple way to set up that simple two-way interaction. And then, we have all the rest of the scene is set up with different stations that highlight different aspects of the XRI toolkit. So we have, the basic 2D UI over here and how that's wired up, sliders, buttons, all of that. We have our 3D UI, and this is where we showcase some of our intention filtering. So you can see there are some of these controls that are very close together. So when you enable these checkboxes up here, it actually turns on the intention filtering and lets you see real time how that impacts what the user sees and does in the scene, which is kind of cool. These are also all just grab interactables, but they've been special cased. So this is an XR lever, so it only works in a certain axis. Joysticks, knobs, things like that. Things that we feel are very normal to expect in an XR experience, things that you want to actually grab and play with. Buttons and sliders, things like that. And then we have the physics over here. So basic physics interactions, being able to push open doors, open filing cabinets. This is where we have our lock and key example. And again, in this example, we use the same key access where this lock requires the specific key that will be provided on this key grabbable. Oops. So the key that's sitting here has an actual keychain object in there. So that's it. That's kind of the project in a nutshell. And hopefully it will be released soon for all of you to check out. Now, I'll hand it back to Doreen to tell you what's coming up next.
All right, thanks Dave for the great overview of a project that uses XRI. Let's now talk a little bit more about what's coming up with XRI 2.0 and beyond. I first would like to say thank you to everybody in this room who uses Unity, who has used XRI, as a lot of the feedback we've received about the toolkit has gone into directly influencing our near-term roadmap. So if we take a look at some of the key highlights that we're really working on today, things like extensibility improvements, things like a controller and interactor refactors with keyboard and mouse simulation for the device simulation, right? So how do we better interact with keyboard and mice through devices themselves? We've also gotten a lot of feedback on our documentation and sample projects, right? How can we make them better? The project we just showed you today is something we're actively working on, and the hope is that we can release that to you in the near future. So as we go ahead and we address this feedback, we then take a look at expanding what XRI can really do for you today. So things like updated interactions, including dynamic attach points, multi-hand support with multiple solver types, and two-handed grabbing and movement transformations. We're also looking at locomotion improvements, including teleporter directionalities and that optional comfort mode vignette sample we talked about earlier on in the presentation. New and updated interactors, including a poke interactor. So thanks to all of you who have asked for a poke interactor. We've heard you, we're adding it in, we promise. Also, new UI interaction improvements, right? So updated customization of input actions and input manager settings, so it's a little bit easier for you to use. I will note that some of this work is already in our 2.1.0 pre-release package. The rest of what's coming up will be coming in imminently. So think, scale of months, not years. Finally, we take a look at what's next. You got the mouse? Good. So we take a look at what's next, right? So how do we take this expanded set of features and use it with an even broader array of inputs? So we're looking at things like revamping controllers and input handlings to take new forms of feedback. Once we do that, we can start thinking about interacting with eye, gaze, and hands, right? So what does it mean to have gaze-based interactions, additional input for user intention filtering with things like eyes and fingers, and other interaction systems for selection and throwing. So things like, can I look at a point in space, throw a ball with my hand, and have both forms of input have the ball go where the user wants it to go? As we build all of these, right, we understand that our samples and documentation need to improve to accommodate these new features, and so we'll be updating our samples and updating our docs as we go ahead and build all these features out. So how do you get started with XR Interaction Toolkit? We've got this handy-dandy QR code, which if you scan here, will take you to a series of links. First, to our documentation. Second, to a set of Unity Learn modules that showcase XRI. And third, to our detailed roadmap, which showcases the features we're building with XRI. I will note that we do update this roadmap on a fairly regular basis, so this link is the place to go to check to see what's coming up next with the XR Interaction Toolkit. All right. I think we are good for questions. Thank you, everybody, for being here. If you want to raise your hand, and we'll answer anything you have. Yep. There's a Linktree link in the bottom. If you go there, it should work. And I will double check on that QR code to see why it is no longer working. Thank you. Any other questions?
So in your sort of, yeah. So in the editor, the sample that I showed you that was triggering the animation, we have a special component that is actually handling that in-between state. So we're directly controlling the 3D model, so it's not actually triggering an animator.
It's not like a set hold.
No, but you could.
How do you do that in code?
Yeah, you could do it that way. We didn't do it that way, but you could trigger it that way. We just didn't want to set up the whole animation machine and everything for this simple project. So.
Gotcha.
Yes.
Repeat the question.
So that your question was, is there anything that can only be set up in the editor that can't be set up in code? As far as I'm aware, everything can be done in code that can be done in the editor. It was done specifically that way so that people who are building frameworks on top of it have access to everything that XRI can do. Yeah, I can double check on that, but I believe, yeah, everything is exposed. Yep. Yeah, so the question was, can you build custom events on top of our existing XRI events? And yes, you can. You can. There's two ways to do that. We actually have the events exposed, so you can just tie directly into those. Or you can extend the class, and you can receive those events as they come in and pass them off to whatever your backend framework is that you already have set up. That's actually how the MRTK does a lot of their interaction with on top of XRI. So the question was, do we plan to support UI Toolkit as well? As soon as the UI Toolkit has a spatial world space option, then yes, we're going to be looking at that. We're waiting on the UI Toolkit team to extend from screen space into world space so that we can take advantage of it, because it doesn't really make much sense until that is supported. But yeah, we're very, very interested in that.
Yeah, I will note that this is not the first time we've received that feedback for that.
Yeah.
We are actively working with the teams at Unity to see how we can align our roadmaps.
Yep.
Can you talk about ease of use of?
Yeah, so the question was if I can talk a little bit more about how MRTK works with XRI. So what I can tell you is that the MRTK3 was built on top of XRI as a foundational layer. So it already, if you're using the new MRTK3, it requires XRI to function properly. So all of the interaction layers, all of that stuff has been built on top of, and it's a good example of what you can do and then how far you can take it. I will mention that they have their own custom poke interactor that they've done while they were waiting for us.
To do our custom poke interactor? Yeah.
Yep, so if you want a poke interactor, they have some really cool UI elements and things like that as well that have been built on top of our UI work as well as their work with the poke interactor. So. Right. Yes. Okay. So your question was essentially what is required by the new input system versus the legacy input manager. So the limitation of the legacy input manager is that you would not be able to use OpenXR. So our Unity OpenXR package utilizes and depends on the new input system package to kind of deliver events and handle the input bindings. And so if you're using OpenXR, it's required to jump over to the new input system. Now, if you aren't using OpenXR, you could use the old input manager to handle inputs that way. And most of that would just have to happen through code. So it's all kind of hard coded. It's not nearly as powerful or as flexible, but some people have seen that it performs a little bit better than the new input system. So depending on your use case, you might have to make some tough decisions. We're working to streamline that and get the performance up. Yep.
Can you talk about
So that's a good question. XRI does not directly expose or unwrap the kind of the inputs that are dealt with, with OpenXR and all the other XR SDKs under the hood. Now, when you import all of the packages, you do have access to write your own scripts that can call into, maybe it's like a custom extension in OpenXR that handles a specific thing, like maybe the hand interaction profiles from, for the HoloLens. So those things you can load and access. You just have to wire them yourself into XRI. And we're working to kind of make that a little bit more flexible, but. Correct. Yeah, that's a very good point, a very good idea. Do you have a use case that you can think of off the top of your head? Gotcha. Yeah, I can tell you that if it's exposed through OpenXR, there's generally a way to pipe that through the new input system. And once it's there, XRI can take it and handle it and do whatever it needs to do with it. Even things like haptics and eye gaze and things like that. So yeah, if you ever get stuck with a problem like that, I highly encourage any of you to reach out on the forums. We're active looking at the forums, checking email, looking at bugs at least once a week. So me and the team, the engineers, are actually actively involved in communicating with the community and trying to answer your questions and things like that. So hopefully you don't feel like you're being ignored. And if you are, you can just make a little more noise, and we're more than happy to help.
Between the forums and the feedback requests on our product board website, we do take a fairly active look at what the community is looking for. So feel free at any time to reach out through any of those avenues. We really look forward to your feedback.
Any other questions, thoughts? So your question was, is there any existing support for, say, hand tracking or hand poses or anything like that? Currently, we do not have any native hand support. We're actively working on it. I do know that the hand interaction profiles that come from the HoloLens and some of the other gesture support exposed through the AR Foundation are accessible through XRI. or through the input system in general. But yeah, just like being able to track individual digits and things like that, that's coming in the future.
But so
If you want, yes, if you wanted to do it that way, or if you wanted to map like a pinch with the hand or something to an action, yeah.
All right, any other questions? All right, well, thank you very much for the time. We appreciate you being here.